Welcome back, everyone. We're going to be solving LeetCode 125, valid palindrome. So a phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forwards as it does backwards. Alphanumeric characters include letters and numbers. So we're given a string S. We need to return true if it is a palindrome or false otherwise. So we can see our input string converts to all lowercase alphanumeric characters, and it's true, it's a valid palindrome. So race car is false, not a palindrome, but they do say the space is a palindrome, or the empty string is, okay. And S consists only of printable ASCII characters. Now, I think the reason why this question has a lot of downvotes is because they just said the string is going to be alphanumeric characters, and there's a test case that you'll fail if you don't check alphanumeric and you only check the ASCII characters. But otherwise, I think this is a pretty good two-pointer problem to test your knowledge. So we're going to solve this question with 2 pointers. We'll say left is going to be equal to the very first position in our string. We'll say right is going to be equal to the very last position in our string. And what are we going to do? Well, we're just going to compare the letters at the pointer locations. If the letters do not match, we know it can't be a palindrome, right? Because it has to be the exact same forwards as it does backwards. So we can say while left is less than right, what are we going to do? Well, first we need to check if these characters are alphanumeric. So we'll say if they are not, if not S of left dot, and we can check that by saying is alnum. This will check if it's an alphanumeric character. What are we going to do? We are just going to update our pointer. We'll say left plus equals 1. So if we run into a comma or a space, right, we'll just increment 1. If we're at the comma, increment 1, we go to a space, increment 1. Okay, now we can check for the letters. And then we'll do the same thing for our right pointer, elif not s right, that is alnum. What do? We update our right pointer, decrement it by 1. Okay, now what about the case where we want to, check these characters, compare them? Well, we have to essentially check the lowercase characters, right? Because we could have uppercase right here in Panama and a lowercase in plan, and we notice that they are checking all the lowercase characters, right? So we can say if the character at our left pointer position, we'll convert it to dot lower if it needs to be. If that is not equal to s of, or the character at our right pointer position, convert it to a lowercase character if we need to. If this is not true, we know it can't be a palindrome, so we just return false right away. Otherwise, we will eventually exit this while loop after, of course, incrementing our pointers. We'll say left plus equals 1, right minus equals 1, right? So after we exit this while loop, we know we have a valid palindrome, so we can just return true. So let's run this. And we do pass the test cases. We'll submit. We pass. Okay, perfect. Go back to the description. So what are the time and space complexities for this problem? Well, the space complexity is going to be constant. We're not creating any new data structures at all. So it's going to be O of 1 for space. Time complexity is going to be O of n. We're just looping through our character string and making some comparisons. So that will be O of n. And that'll do it for LeetCode 125, valid palindrome.